right? Today's session we will look for understanding a built-in function which is available in C language. A built-in function which is available in C language, that is called as QSort function. Okay, it's a QSort function which is available right in C language. Okay, in C language. Okay, so basically this function is used right to order an array. Order in the sense you can call it as sort. We can call it as sort. Okay, we can call this as sort. Okay, so but this function needs a comparator function, right, to determine right the order of how to arrange right the elements. Okay, so this is what right you need to understand. There is a built-in function right which can be used to sort an array, right? So what is the syntax of comparator function? Syntax for comparator function, right? So return type is int followed by comparator, right? You can give the name anything you want, followed by two parameter constant void star a comma right constant void star b. Okay, this is the syntax of right a comparator function, right? You can write the statements here. So this is a user defined function, right? It's a user defined function. It's a user defined function. This is how we need to write the comparator function. So right, first let's understand void pointer. Void pointer, it can store address of any data type, okay. So right next thing is there are certain rules right for defining comparator function, right? There are certain rules for defining comparator function. Let us look at what are those rules. Okay, so the first rule is right, first thing you need to understand, a and b are pointers. A and b are pointers to the elements to be compared. The elements which you are comparing, the address of those elements will be passed as a parameter to this function, right? And return values, return values, right? It can return only three values: less than 0, right? It can return less than 0, right? Okay, second one is it can return 0. It can return 0. The third one is it can return greater than 0. Okay, it can return greater than 0. So what happens when you return value less than 0, right? Right, if the first argument is placed before second, right? If the first argument is placed before the second, in that scenario, right? In that scenario, it will return, if it returns 0, right? Both are same. When both are same, both the arguments are pointing to the same value, right? So if the first argument for the third one, first argument is placed right after sorry, after the second, right, argument. That is what we need to understand here. So these are the three return values that you should remember. It must return only these values. One is greater than 0, less than 0, and another last one is 0. And a and b are pointer to the function. A and b are a pointer to function. Okay, now what we will do is we will write a function here. Okay, we will write a program to use, right, to make use of, right, the quick sort function which is present in C language. So hash include. So what program are we writing? Right, program to sort the array elements using q sort. Okay, so first of all we need to write a comparator function. We need to write a comparator function. So here return type is int. You can give the name for the comparator anything you want. You can give it as comparator or comp, or give your name as a function name. That is up to you. Then you will have a void pointer, constant pointers, right? Here the values will be constant star b, right? You can give the variable names whichever you want. Now return the difference between a minus b, but a and b are two pointers. So what we have to do is we need to fetch the value and send the difference. We need to fetch the value and send the difference between the two values which your a and b are pointing. But a and b are void pointers. They are void pointers. A and B are void pointers. So you need to, if you want to dereference them, you need to typecast it to the data type which you want, right? Int star. So this is called as typecasting. This is called as typecasting. You are converting the void address which is present in B to the integer address. Then you will apply star to fetch the value. So the difference between these two, this is what we're gonna return. We're gonna return the difference between these two values which you are sending. Now int main opening bracket. Okay, int main opening bracket. So before continuing with this one, let us understand the syntax of qsort. Now we have understood, right, the syntax or how to write the comparator function. Now syntax of qsort function, right? Let's look at it. Qsort. So first of all, name of the function qsort, followed by base address from where you want to sort the array elements, base address, then size of the array, then size underscore t means size of each element, size of each element, then comparator function. This is the syntax that we need to write. So size underscore t is size of each element of that array. Okay, and comparator is a function, right? Comparator is a function or base address of function, address of function. So you are passing a function itself as a parameter to another function. You are passing function itself as a parameter to another function, right? So this is the syntax that we have to use to sort the array element, to sort the array elements. Okay, okay, one second. Okay, now let's concentrate on the program now. So what we will do is we will declare an array here. We will declare an array with certain size int n, right? Int n number of elements, and we need I variable. Okay, so printf enter size of the array, enter size of the array, scanf percentage d double quote comma ampersand n. Once you get the size of the array, then what we will do is, right, we will read the array elements, enter elements, enter the array elements. Okay, to read the array elements we need to traverse the array I less than n, I plus plus. Okay, then read all the values, scanf percentage d double quote comma ampersand arr of I. Once we get all the elements, so now what we need to do is we need to sort using qsort function, the built-in qsort function. We need to sort the array, right, in ascending order. Let's do it in ascending order. Okay, let's do it in the ascending order. Now let's write the function qsort followed by what is the base address of the array? It is ARR. Base address of the array is ARR. Then how many number of elements are there? N number of elements. What is the size of each element? Size of int. Because all the elements of the array are of type int. So we will pass the third parameter as size of each element. Then a function called as comparator, right? Now after that, if you print all the array elements, the array elements will be sorted in ascending order, right? Slash n array elements. Let's print all of them to see whether they are sorted or not. Okay, to print the array elements, again we need to traverse, again we need to traverse. Okay, comma arr of I, right? So let us execute this code and see, right? Let us execute this code and see. Okay, implicit declaration of qsort function. Once again, it is giving a warning because the qsort function, prototype of qsort function is present in the header file called as stdlib.h, right? Prototype of, right, qsort function is present in stdlib.h, so we need to include that header file. So let's give the element 5 elements, enter the elements 3, 5, 2, 1 and then 7. So are the elements getting sorted in ascending order? Whether the array elements, are they getting sorted in ascending order? Now if you want to do a descending order, now if you want to do it in descending order, now the only thing is you need to change these parameters. Now you need to send b minus a, right? You need to change these parameters so that the entire array will be in a descending order, right? So give the 5 elements, I will give all the elements in ascending, you will see the output in the descending, right? So only the difference is, right, you have to change the values here. First argument minus second argument, that means ascending order, right? If you go with second argument minus first argument, then it will become descending order, right? So that is how we use this built-in function qsort, right, in our programs. This built-in function can be used, right? This built-in function can be used, right, can be used, right, when sorting is a very small part of your program, right? This built-in function can be used in your interviews also when the sorting is a very small part of that program. If they ask you to do a bubble sort, then you should not write this. If they ask you quick sort, you should not write this, right? You have to build your own logic for that. Okay, I hope you guys are clear on this. Thank you for this question. The next example that we're going to start is, right, chocolate distribution problem. Chocolate distribution problem. This is quite a common problem which keeps on repeating in the interviews. See, I have given you this problem is known as, or it is famous as, chocolate distribution problem. But in the interviews, you might get a different story other than chocolate distribution. They might change the right storyline of that question. Right. First, let's look at the problem statement. Given an array, right, of n integers, given an array, right, of n integers, where arr of I represents I represents the number of chocolates, right, number of chocolates in, right, ith packet, right. It represents the number of chocolates in ith packet. So each packet, right, have a variable number of chocolates. Each packet will have variable number of chocolates, right. So there are m students, there are m students, right. The task is, right, the task is to distribute the chocolates, distribute the chocolate packets such that, right, the first question, each student gets exactly one packet. Each student will get exactly one packet, right. And second condition is the difference, right, the difference between, right, the maximum, right, maximum and minimum, right, minimum number of chocolates into the students is minimized, is minimized. So this is the question they have given to you. Okay, so let me explain what exactly is this question. Can we start with that? Let us take a sample input. So let's take the array as 7, 3, 2, 4, 9, 12, and 56, right. And the number of students is equal to 3. Okay, so what will should be the output of this, right? So output of this is, right, 2. So let's look at the explanation. Let's look at explanation. See, if you distribute, right, 3 packets, if you distribute, let's distribute the first 3 packets to 3 students, right. Now out of these 3 elements, right, let's look at the first case, right, sorry, the first case, right, 7 comma 3 comma 2. If you distribute these packets, now out of these two, right, out of these 3 packets, right, which is the biggest value? 7, right, and which is the smallest value? 2. So what is the difference between these two? The difference between these two is 5. Now if you look at the second case, if you look at the second case, where, right, if you give the chocolates as a 3, 2, and 4, right. Now, right, the next one will be, right, the next one would be, right, the smallest biggest value here is 4, and the smallest value is 2, and the difference is 2. Now if you go with similarly the third case, if you go with the third case, right? So 2 comma 4 comma 9, right? Now in this one, biggest value is 9, smallest value is 2, and the difference is 7. So like this, if you keep on doing it, you should get the difference as smallest, right? You should get the difference between the biggest number of or highest number of chocolates and the lowest number of chocolates. The difference of that must be minimized, means you should get the difference as smallest. So like that, when you try it, this combination will give us the lowest difference. If you look at the difference for the first case, it is 5. Now the difference is 7, but in this case it is true. So if you do it for all the elements, then the output will be the 2. So in short, right, I'll explain this in other way. Find the sub array with size m, right, right, whose maximum and minimum element difference is least, right? So find a subarray with a size m whose maximum and minimum element, right? Maximum and minimum element of subarray, sorry, I'll just frame the sentence in a right way. Okay. Find whose difference between maximum and minimum element of subarray is least. Are you guys, I hope you guys are clear with the question. Okay, we'll start discussing about solution, type of solutions we can build solution, right? So what name method is, right? The very basic method is subsets, right? So by generating, right, all subsets, right, by generating all subsets, you can start doing that job again and again. But in this one, the time complexity, right, the time complexity will be, right, very huge. So for that reason, we will go with the expected approach, or, right, this is the approach that needs to be followed. We call it as two pointer technique. Okay. So the two pointer technique, what we will do? First, sort the entire array in ascending, right? First, sort the entire array in ascending. Okay. Okay. Then find the difference between first and last element of each window, right? Keep track of smallest difference, right? So here the task is, right, because here we have the fixed window, here we have a fixed window, here we have a fixed window, because the window size is m, window size is m. So once you start from the first element, right, as a first pointer, the second pointer will be third element. We will look at this in a pictorial representation. Okay, let's start solving this one in a pictorial representation. Okay, now first what we will do is we will create an array. Okay, we will create an array. Okay, let's select. Okay, let's select. Okay, we will create an array. One second, I'll change the size. Okay, So let's create an array, right? So how many elements we had? We had total 7 elements. So which is 7, right? 7, 3, okay, 7, 3, 2, 4, 9, 12, and 56. So these are the array elements that we have. 0, right? 0, 1, 2, 3, 4, 5, 6. So here the number of elements is equal to 7 and m is equal to, right? If m is equal to, right, 3 number of students, and we need one variable to keep a track of minimum difference. Initially minimum difference, I'll take it as largest value, some largest value I'll take. I'll tell you how to take that largest value also. Okay, keep largest value as a large. Okay, now, right, we will start with the, right, first step, that is you need to sort the array. Now, right, now go ahead with sorting. Now I'll just copy that image, this image. Okay, now create a duplicate and keep it here. Okay, so the first step is to sort the array, right? So if you sort the array, what will happen with all the elements? Now the first element will be 2, next is 3, 4, 7, 9, 12, and 56. So this will be, right, the first, right, array representation after sorting. So the what is the next step once we sort, right? Next step is you traverse the array. Traverse array, right? Traverse the array. Now what we will do here is we will start comparing ARR of I, right? Okay, see, I'll show you the first pointer. This is the first pointer I, and this is I, sorry, m minus, sorry, I plus m minus 1. So this is our fixed window. This is our fixed window. Now what we will do is ARR of I plus m minus 1. This element minus ARR of I. If it is, right, if this element is smaller than assumed minimum difference, right? Okay, then update, update, right, minimum difference. Okay, so after that, next what we will do, next after that we will move the pointer to the next window, right? Our next window will be like this, right? This will become I, this will become I plus m minus 1. Now you start looking at the difference in the second window. Now you start looking at difference in the second window and keep a track of it. Or do you want me to create what you call, one second, I'll just create duplicate copies of that, so it will help you to understand. Okay, now I'll select this. Okay, create duplicate, so keep it here. Okay, now one second, I'll just create a multiple copies of these duplicates so that it becomes easy for us to explain the complete code. Duplicate, duplicate, just keep multiple of them. One second now. Now this cannot be undone now. Okay. I have to like select one by one only, not every time. Okay. One second. Let me do it. Okay. We will see it later onwards. Now, coming back to where we have stopped. So I will assume the largest value of integer, right? I will assume some largest value of integer. So let's say it is 9999999. Now, if you look at this difference, right? If you look at that difference, right? Minimum difference is 99999, some bigger value. The difference between 4 minus 2, it is 2. So now 2 is lesser than this value. 2 is, right? One second. 2 is lesser than this value. Then update minimum difference is equal to 2. Now after that, go for the next window. Now go for the next window. The next window will go from here I, and this will become I plus m minus 1. Now you look at the difference between 7 minus, right? Now the difference is 7 minus 3, which is 4, right? Less than 2. Condition fails. Then don't do not update do not update minimum difference. Okay. Then go for the next element. Go for the next element, right? Go for the next element and create a third window. The third window will be here. So this is your starting point I. This will be your ending point I plus m minus 1. Now check the difference. Now check the difference here. Now check the difference. It is 9 minus 4 less than 2, which is 5 less than 2. Condition fails. Do not update. Do not update. Okay. So like this, right? Till where this entire thing should keep traversing. Now the next window will be starting from here, right? This will be the next window. This will be our next window, and this will be a starting point. This is I plus m minus 1, and the difference is 12 minus 7 is less than 2, right? Again the condition will fail here, right? Then do not update minimum difference. Do not update minimum difference. Okay. Now similarly you need to do it for the last possibility. Now you need to do it for the last possibility. Okay. So let's create a duplicate of this. Okay. Let's create it and keep it here. Now we need to do it for the last window. So last window possible is here. This is our last window. So this is I, and this is I plus m minus 1. So if you look at the difference here, 56 minus 9 less than, right, 2. Obviously the condition will fail here. Again, do not update minimum difference. Minimum difference. Okay. So once you traverse and finish it, right? Once you traverse and finish it, right? Once you traverse and finish it, right? You come out of the loop and print minimum difference. Let us write a code for this. Before we start writing a code, there is one more thing you need to, right, understand. Limits. limits of data types, right? For example, right, there is a predefined macro int minimum, right? Its macro, it gives smallest value of signed integer. Okay, it's a predefined macro, you can use them. Now int max, right, it gives biggest value of signed integer, signed integer. To use these macros, we need to include, right, limits dot h header file. Nowadays this header file is present in all the compilers which you guys are using in the interview, right? Every compiler has this limits.h, right? I told you, right, we need to assume some largest value, so I'll take this int max as a default one. Okay, so let's start writing a program for this one. So hash include stdio.h and hash include limits.h. Okay, int main. So let's declare an array int arr of 50, then int I comma n comma m. So we need these, right? We need these, okay, values. Now the second one is, right, second step is read size or enter size. Okay, scanf percentage d double quote comma ampersand a, sorry, ampersand n. Once we get this number of elements, right, next thing is read array elements, enter elements, right? So to read the array elements, we need to traverse the array, right, and read the values from the user percentage d double quote comma ampersand arr of I. Once we get the number of element, next thing we need is, right, the number of students, enter students, right, enter number of students. Okay, so scanf double quote percentage d double quote comma ampersand m. Once we get all this information, next what we will do is we will call a function. So here what we have to do, what we have to print, we have to print, right, okay, we have to print the result here. So the result is percentage d double quote comma find minimum difference, right? Let's give the name as find minimum difference, or you can call it as chocolate distribution problem or chocolate distribution. You can call any name you want. So we need to pass the array and number of elements and number of students. So rest will be taken care by the function. The function will find the difference and return that integer value. Okay, so okay, chocolate distribution, it returns, it returns, it returns minimum di minimum difference. Okay, so return type will be int, then the function name is chocolate distribution. The first parameter is array, second parameter is number of elements, and the third parameter is m, that is the number of students. Now as I've told you that the first job is what, the first job to solve this problem is we need to sort the entire array in ascending order. So for that I need to write a qsort function, arr, which is a base address, number of elements, size of each element int, comma, right, the comparator function. So these are the parameters I need to send. So sort the array in ascending. Okay, Now I need to write that comparator function. So int comparator constant void star a void star a comma constant void star b. Inside this, right, we need to send the difference of first and second element. So return, right, star inside bracket int star a minus star inside bracket int star b. Okay. So once you finish the sorting, now what we have to do? I need to take one variable called as minimum difference. Minimum difference is equal to, I will assume the largest value of integer. I will assume a largest value of integer which is given by int max, int underscore max, and it's a macro defined in limits.h. Limits.h. Now what we need to do? Traverse the array. Traverse the array, right? From 0 to till where we have to traverse? We need to traverse till, right? Okay, or you can go with another traverse till, right, I plus sorry m minus 2 till m minus 2 or m minus 1, you can call it as, right, sorry, not m, it is n minus 1. Okay, till the last element you need to traverse till the last element. So you can write it as int I. Okay, I is equal to 0, then I plus m minus 1 less than n. Okay, I plus m minus 1 less than n, I plus plus. Inside this, right, inside this, right, find the difference here. Find the difference. Difference is equal to, right, ARR of I plus m minus 1 minus ARR of I. So first element and the third element, find the difference and check if, right, difference is smaller than assumed difference. See, this is the difference just now we have found for the first window. If this difference is smaller than assumed minimum difference, then update the minimum difference. Right, so do it for the entire array for all the windows. Once you come out of the loop, then return minimum difference that you have found. And here I need to declare some variables, that is int I, and I need to declare difference. Okay, and minimum difference also, I'll just remove this line and keep it here only. Okay, sorry, this must be int max macro. So this is for today, right? I hope you guys have understood and you have learned something better.